Hi everyone, this is Babaiah, Assistant Professor of AC Department from MLR Hyderabad. Today I am going to explain about the transient or time response of first order system for unit ramp input. Previous sessions we are just discussed already for the time response or transient response of first order system for any signal, that is like for unit impulse signal as well as unit step signal. For the today's session, just we are going to change the input signal. That input signal is here we are going to apply the unit ramp input. For this condition, we are going to calculate the or derive the transient or time response of the first order system. Let's move on to the overview of today's session. Just here, the calculation or derivation of the time response of first order system for unit ramp input, and also we are going to draw the graph for the response of the first order system when apply the input as a unit ramp input. Just here I am going to consider the first order closed loop control system with a unity feedback system. It is shown in the figure. Just observe. Just I am going to consider the first order system with unity feedback system it is shown in figure. First order system with unity feedback, right? With unity feedback, just here same way, same procedure to follow the previous transient or time response of the any signal like unit step as well as impulse. Same we are going to use the same procedure for the ramp signal also. Just here see, observe the transfer function of the given first order system is directly C of S equals to, or C of S divided by R of S is nothing but the 1 by 1 plus st or ts, or just it is in numerator. Once again I am going to repeat here, shortcut here for a unit impulse for a unit of unity feedback system, that is the h of s equals to 1 unity or unity feedback system. For any unity feedback system, just we are going to calculate the transfer function. Simply the open loop gain in open loop gain numerator term directly adding in the denominator term, then you will get the transfer function of the any unity feedback closed loop control system. That is here, observe, in numerator is what, 1 value is there, in denominator ts is there, 1 plus ts, that is the transfer function of the first order system with unity feedback system, right? Unity feedback condition, directly this is the transfer function, and here C of s equals to R of s into 1 divided by 1 plus st or ts. Now I am going to apply the input is what, for input is ramp or unit ramp signal, unit ramp input is unit ramp condition, that is the R of t equals to what, t, R of t equals to t. So apply the Laplace transform to this equation. So R of t, Laplace of R of t, that is equals to Laplace of t, that is R of s is Laplace of R of t is nothing but the R of s is equal to t is Laplace of t is nothing but 1 by s square. Just here substitute these two values. Here R of s equals to 1 by s square. Substitute in this equation. For example, I am going to consider the equation 1. Substitute R of s value in the equation 1. Substitute R of s in equation 1. Then we are going to get C of s equals to C of s equals to R of s is nothing but here 1 by s square, 1 by s square, and here 1 divided by 1 plus st, right? 1 by s square into 1 by 1 plus st. Apply here, after that apply the inverse Laplace transform to this equation. For inverse Laplace transform for this equation, just here equation 2 I am going to write equation 2 simply. Next here C of is apply the inverse Laplace transform to the equation 2. That is, equation 2 is nothing but what? Equation 2. From equation 2, C of s, here apply inverse Laplace equals to C of s equals to what equation? 1 by s square, inverse Laplace of 1 by s square, 1 by 1 plus st, 1 by 1 plus st, 1 by 1 plus st here. Next I am going to just use here, just I am write this equation into inverse Laplace of directly 1 minus st and plus 1 minus st divided by s square. This term is just I am going to write 1 minus st divided by s square plus 1 plus or t square divided by 1 plus st. See here, observe this one. 1 minus st divided by s square plus t square divided by 1 plus st. Just I am just writing this form. Here observe. In denominator, s square into 1 plus st. Just s square into 1 plus st. Here also s square into 1 plus st. In numerator, just 1 minus st into 1 plus st. What? 1 minus st into 1 plus st. What the value? Here just I am going to get the a minus b into a plus b, right? A minus b into a plus b is a square. So 1. So 1 a square minus b square, that is s square into t square. Here just s square into t square value plus t square divided by s square into here s square t square, here s square into t square this value, and s square into 1 plus st, right? 1 plus st. Here observe 1 minus s square t square, this term and this term, these two are get cancelled. 1 by s square into 1 plus st, same you are getting 1 by s square into 1 plus st. So just we are going to simplify this equation into, or we are going to write in the terms 1 minus st divided by s square plus t square by, this is also no problem. So inverse Laplace of c of s is nothing but here c of t, that is equals to this. Next by apply in separate terms, I am going to write the separate terms here. Inverse Laplace of 1 by s square, sorry, here writing 1 by s square, 1 by s square, and here minus inverse Laplace of st divided by s square. So 1 is cancel, so 1 by s is there here, t into 1 by s, and here plus inverse Laplace of here t square divided by 1 plus st, or 1 divided by 1 plus st. Here observe inverse lap 1 by s square is nothing but here t, and minus 1, here 1 by s is nothing but here, just simply I am right inverse Laplace of 1 by s is nothing but t, and inverse Laplace of 1 by s is nothing but 1 by s is nothing but 1 or 1, and also here 1 by inverse Laplace of 1 by 1 plus st is nothing but e power of minus at. Just remember all these formulas, just I am going to write here inverse Laplace of 1 by 1 plus st 1 by 1 plus st, that is equals to e power of minus 80. E power of minus 80, right? These three formula just apply here. Same. 1 by s square t and inverse Laplace of 1 by s. Already t is there. 1 by s is 1 and plus here inverse Laplace of here t square is already available. 1 by 1 plus st is nothing but e power of minus 80. A in place of a. In place of a, just 1 plus st. A. T, just a equals to capital T, so that is minus t divided by t, e power of minus t divided by t. Simply I am going to write here. Okay, t divided by s plus, just I am going to here one thing. You can do one thing here directly. You will get here inverse Laplace. I am going to here, t is available right here already. T square is available. So just I am consider the common as 1 by t plus s. Here t and t both 1 t get cancelled. So I am going to write t minus t plus here inverse Laplace t divided 1 by 1 plus st form. Now it is good. So t into e power of minus t by capital T. Here 1 plus st or s plus a form, right? 1 by, here I am going to write here, sorry, 1 by s plus a. This is 1 by s plus a. S plus a. Here a equals to 1 by t. A equals to 1 by t. Here a equals to 1 by t. Just consider as inverse Laplace of 1 by s plus a, right? So just e power of minus 80, where a in place of a, just substitute 1 by t. 1 by t is here, already t is there, minus t by t. This is the response. C of t equals to t minus t plus t into e power of minus t divided by t. This is the response of the first order system for unit step unit ramp input. Unit ramp input, this is just I am going to write here C of t equals to, in next slide, C of t equals to, I am going to write again here, C of t equals to t minus t capital T plus e power of minus t. Here one more capital T into e power of minus t divided by capital T. Next, for ramp output, we have some error, right? Here, here see, this is the ramp signal, right? Ramp signal, in ramp signal we have some error is available for ramp signal. For ramp output, have some error. So I am going to consider here error signal or error in ramp output. So error signal is some inbuilt. So e power of t or e of t equals to the input signal r of t minus and the output signal. This is the definition. Error. So error signal is nothing but what? Error signal, the definition of error signal is nothing but the input signal and the output signal. Here just already previous in first unit we discuss here. This is E of S. E of S is some error signal or here negative feedback. For example, here I am going to consider here G of S and here C of S. This C of S term, it is in directly into joining into the here negative feedback. So this is the error signal or E of S equals to the differences between the input signal minus the output signal C of S. This is in the S domain. For in T domain, it is E of t equals to R of t and C of t. This is the equation. Okay, this is the equation to get the error signal. Error signal, what is the meaning of error signal? For ramp output we have some error, so that's why we are going to consider the error signal. The error signal is nothing but the differences between the input signal and the output signal of the system. Input signal is the R of t and output signal is the C of t. Error signal is the E of t. Here just we know already C of t. So here R of t is nothing but the input signal. So input signal is here R of t is nothing but input signal. R of t is nothing but input signal. Input signal is here what? Ramp signal. Input signal, that is the ramp signal. So ramp signal. Ramp signal is nothing but what here? Ramp signal is nothing but t. So that's why here E of t equals to R of t. In place of R of t, just I am going to write the t, and minus C of t I am going to write t minus t plus t into e power of minus t by t. Just here observe, t minus t, this will be 0, and plus t minus t into e power of minus t by t. T minus t is 0 and t minus t into e power of minus t by t. Next, E of t, that is equals to, here common the t and 1 minus e power of 1 minus e power of minus t divided by t. Here 1 minus e power of t divided by t. Just observe E of t, this is the error signal, t into 1 minus e power of minus t. T minus t, here t is just common, 1 minus e power of t, and here just observe this signal, observe this one. Error signal is equals to what? T into 1 minus e power of minus t divided by t. For the error signal, find it, or means here I am going to consider the final value theorem. From that the steady state error is nothing but what? ESS equals to limit S tends to ESS. Steady state error is, what is the steady state error for any signal? For the final value theorem, by applying the, or by using the final value theorem, just we are going to see here one thing, one more point here. Just observe, error signal is nothing but what? Error signal is nothing but the difference between the input signal as well as the output signal. That is nothing but the error signal, right? Here error signal is, in our ramp signal we have some error output. When we are going to apply the ramp signal, we get the some output. In that output we have some error. That error is nothing but the error signal. So that's why we are going to calculate the error signal. E of t equals to R of t minus C of t. Here by steady state error, steady state error for time domain is, what is the value steady state error here? Just I am going to consider steady state error. Steady state error ESS in time domain. In time domain, just I am going to consider steady state error. ESS is steady state error, that is equals to limit t tends to infinity E of t. Here we know that E of t is the error signal. Here apply E of t. Okay, just apply the or calculate the steady state error. That error is the steady state error. So steady state error, limit t tends to infinity, that is E of t, error signal. We know E of t already. T tends to infinity. E of t is nothing but here what? E of t equals to t into 1 minus e power of t divided by t. 1 minus, here t into 1 minus e power of minus t divided by t. So here t tends to infinity, substitute here. 1 minus e power of minus infinity by t. Infinity by something is equals to infinity only. So 1 minus e power of minus infinity. Here just e power of minus infinity equals to what? 0. E power of minus infinity equals to 0. For that, just substitute here t 1 minus 0. You will get the what value here? Directly get the ESS, that is steady state error, that is equals to 1. So ESS equals to time constant. Simply time constant. The error is nothing but here what? Here ramp input, and I am going to get the some output. The difference between these two signal is nothing but the steady state error or error signal. Here steady state error, that is this is input signal and output signal. This is output and this is input signal, and this is the graph of ramp first order system figure. First order response of first order system for unit ramp input. Okay, unit ramp input. What we done here? Just to apply the input signal as a ramp signal to calculate the time response or transient response for the first order system. Just we consider the first order system, that is here first order system with unity feedback system. From that we calculated the transfer function. This is my transfer function C of s. We know the input signal as a unit ramp, so R of t equals to t. Here apply the Laplace transform to the input signal. For R of t is nothing but in time domain, that is considered converted into the s domain. R of s equals to 1 by s square. Finally we got the C of s, that is the response of the system in s domain. After that apply the Laplace, inverse Laplace to the s domain equation. Finally we got the time domain or response or transient response or time response of the first order system for unit ramp signal. But in a ramp signal has some output in a output. When we are going to apply the any ramp signal to the system, we have some errors are available, or we are getting some error in a output. For that error we are going to calculate that steady state error. So that error is nothing but, or error signal is nothing but the difference between the input signal and the output signal is nothing but the error signal. So we know the R of t is nothing but the t, that is the input signal is the ramp signal, and the C of t is known as the response, that is here substitute, and you will get the error signal. A steady state error for in time domain is nothing but the steady state error limit t tends to infinity, and error signal is e of t. We know the e of t, just substitute here, and in place of t just substitute the infinity. You will get the time constant. The steady state error is time constant. Simply in ramp signal the steady state error value is t or time constant, where t is the time constant. Time constant. I hope you understood every point how to determine the transient or time responses of any input signal, like unit step or unit ramp or unit impulse, unit parabolic, like that we are going to do. Okay, this is the procedure to calculate the transient or time response of the first order system for unit ramp signal or unit ramp input. I hope you understand each and every point. I think you thank you all.